Okay, well, okay, we have a third person now. That's good. Um, okay. Well, welcome everyone to our sixth advanced Python class, Python 2. Uh, so we can just get started here. Can everyone hear me okay?
Yes.
Okay, good. Um, so from last class, we were talking about recursive functions, but I would like to, uh, okay, I'll work with you in a moment, Ivan. But before I get into recursive functions, I'd like to review the solution to last week's homework, the homework that was assigned from last week. So let's open up the instructions for that homework, and then we can talk about the solution to it together. Okay. So from last class, we had a homework assignment where we were to write a function that can take any number of strings, and it will return the longest string to the caller. And then we are supposed to write a script that would take a user input for 4 inputs, and then return the longest of the input. Um, so I'll just bring up a sample solution. Um, So this is the sample solution that I wrote up to the homework problem. Uh, so I use so for the function, I call the function that finds the longest string. I called it find the longest string, and I have it up here at the top. And I use the star args argument. We learned about that last class. Um, so can anyone tell me if they remember what the star args argument or the star args syntax means for functions? Yeah. Well, star args allows us to iterate through the arguments to a function. So it essentially allows us to um, put in as many arguments as we want into a function call, which is what we want to do for the homework. So in this solution, I created an empty list called user strings. And then I started to iterate. Since we want 4 strings, I made a for loop from that counted from 0 to 4. And then I would print out, and then I would ask for user input 4 times. And then I would add the user's input to my user strings list. And then after that, in this line, I would call the find longest string function on the on the strings that the user put in, and then I'll just print out the longest string. So if I were to run this program, enter string 1, I'll put Kingsley. Enter string 2, I'll put Austin. String 3, I'll put Henry. And string 4, I'll put Ivan. So I put in the 4 strings, and then my script tells me that the longest string that I entered was Kingsley, which is correct. Because, okay, I guess I used one little thing here. So to find the longest string, I did max of args, of all the arguments, and then for the key, I used the length of the argument. So this was something that we learned a while back, maybe towards the beginning of the semester of this class, this syntax. So yeah, Are there any questions about the solution? All right. Okay, so are we good to continue on to recursive functions? Just give it a yes or a thumbs up if you're ready to move on to recursive functions today.
Okay.
All right. Okay, I'll post the solution to the Google Classroom so that you guys can have it as reference. And Ivan, were you able to take a look at the link that I sent you maybe an hour ago that kind of outlines how to install PyCharm?
Yeah, I got PyCharm. I just need help setting up the files.
All right. Okay, so is everything good now?
No, because when I try to run something, like I think like I remember on the first day we had to like create a folder, I think, for the project. Now, but when I run it right after installing it, then it's not working.
Okay. Would you mind sharing your screen so that I can see what you're talking about? I'll see if I can allow you to share your screen here. Are you able to like demonstrate what you mean? Are you getting like some kind of error?
I think I can share my screen. I think you just have to stop sharing first.
All right. Yeah. So let's see. I'll quickly take a look at what issues you're having, and then we can move on to the lecture for today.
Yeah. So, like, if I run it here, oh, it does work. But will it? So it does work.
Oh.
Huh. Well, if I come upon any other issues, I guess I can ask you again.
Yeah. Yeah. I guess your PyCharm wanted to behave yourself now that I'm seeing, now that I'm looking at it. Okay, so that's good. All right, great. That was a quick solution. Okay, let's move on to recursive functions then. Okay. So can anyone tell me in their own words what a recursive function is? Just trying to jog our memory from last class. Okay. So in short, a recursive function is a function that calls itself. That's the main takeaway that I want you guys to get from recursive functions, because the details can be pretty hard to understand. So in this example, actually I'll show an even easier example. So in this example of recursive function, this function that's called sum_pos, it's recursive because in the function itself, it calls itself again down here. Okay, that's why this function is recursive. And from last class, I said that the two main aspects of a recursive function is that there needs to be a base case. So this right here is the base case. And the second main important thing about recursive functions is that there has to be some progress made So in this else statement, this is where the progress is made. So we call some pause on x minus 1. That's where progress is made. So yes, this function is recursive because it calls itself. Now let's work on this exercise together. We're going to write our own recursive function, okay? So we're going to write a recursive function to find the factorial of an integer. Now, can anyone tell me what the factorial of a number is? I have it on the screen too, but I want to engage you guys. Yeah, Audrey?
From that number down to 1.
Yep, good. Though it sounded like you were kind of cutting in and out there, but I got the gist of what you were saying. So a factorial of a number is the product of all the integers from 1 to that number. So so for example, 4 factorial is 1 times 2 times 3 times 4. So we can write a function for finding the factorial of an integer in Python, and we can do it recursively. Let's do it recursively. Okay. So can anyone tell me if they remember what the 2 main aspects of a recursive function are? What 2 things need to be done for a recursive function? Okay. So for the first thing that a recursive function needs is that it needs a base case. So for finding the factorial of an integer, the base case would be 1. The base case would be 1 factorial, because 1 factorial is just 1, I think. Let me actually quickly verify that. Yeah, okay, yeah, 1 factorial is just 1. Okay, good. So that means in our code, we're going to have if x is equal to 1, then just return 1. Does that make sense to everyone? That's our base case. Because 1 factorial is just 1. Now for the second aspect of our factorial function, we need to make some progress. So this is where we will actually call our factorial function again. So does anyone have any idea on what should go in line 5 here? How should we call factorial? How should we make it call itself so that it returns the factorial of an integer of x? Okay, I'll give a hint. We need to have x times something. Yes, Henry?
Is it like x times like all the numbers?
Yeah. And then how could we do that? This is where we need to do our recursive call.
So
I'll give a hint. It's going to be factorial of something. Now, okay, so let's think about the case if x is equal to 2. Okay, so if x is 2, then in the function call, it's going to do if x is equal to 1, and it's not. So then it's going to go down here to this else, and it's going to do 2 times something. And the something that it needs to do is the factorial of 1, because 2 factorial is 2 times 1. So what needs to go in the parentheses here is actually going to be x minus 1. Is it going to be x minus 1? Yes, it's going to be x minus. I'll need to return it. Yes, so we're going to return x minus 1. Okay, so if we were to call this, so 3 factorial is 3 times 2 times 1, which is 6. So if we call this, we'll get 6. And if we put in, let's say 7 factorial is 5,040, which I guess if we had a calculator on hand, we could verify, but 7 times 6 times 5 times 4. So that's going to be a decently sized number. And of course, 4 factorial is going to be 4 times 3, which is 12, times 2, 24, times 1 is still 24. So yeah, this is our recursive function. Let's see. And again, I don't really expect you guys to understand recursion 100% because it is a very hard topic. And typically people don't learn about recursion until undergrad. And usually professors talk about stacks, which is a data structure in computer science when they explain factorials, but I think that's too much detail for now. But the main thing I want you guys to understand is what recursive functions are, which is functions that calls themselves. And I want you guys to understand that a recursive function needs a base case, which in this case is x is equal to 1. And it also needs to have some progress made, which is the factorial x minus 1 part here. Does anyone have any questions about recursive functions? All right. Okay, I suppose we can move on then to, Ashley, are there more slides on recursion here? Let's see. Okay, so we have a quiz. All right, a few quizzes actually. Okay. So here's a quiz for you guys. What is the most appropriate definition for recursion? A function that calls itself. B, a function execution instance that calls the execution instance of the same function. And then C or D. So looking at these options, which is the most appropriate definition of recursion? Okay, it's A. Okay, I'm glad that you guys got that. So yep, a recursive function is a function that calls itself. Okay, next quiz. What will be the output of the following Python code? So we have a recursive function here, test ij. So I'll let you guys take a look at this code for a minute, and then we could talk about what the possible outputs are. right? Okay, so let's see. So we could, maybe it'll be easier to talk about what the answer isn't. So can someone tell me if they think the answer is C or not? And their reasons for their answer? Would this give an infinite loop? Okay, I'll just say that this code will not give an infinite loop because it's always going to stop when I is equal to 0. And because in the last line here, we have test I minus 1, I will eventually go back to that down to 0. So the base case will happen eventually. So the answer is not C. The answer is actually D, 17. And we could verify that by just running this code and getting 17 here. So for this quiz, I would have been satisfied if you guys were able to see that it wasn't going to be an infinite loop because the base case was going to happen eventually. Okay. Any questions about that quiz or about recursion in general before we move on? Okay. All right. I'll just post these quick notes here. And then we can move on to classes, which are very important. Oh, that's weird. All right, can everyone see my screen? All right, let's just move on. Okay, all right. So classes, how can I explain Python classes? Let's see, okay. So a class is an example of object-oriented programming. Now, has anyone here ever heard terms like classes and object-oriented programming before? Yeah, so we're starting fresh then. Okay, so object-oriented programming, or OOP, is a programming paradigm that treats the issues or stuff as an object. Everything is an object. Your code handles objects. So with object-oriented programming, we can define things. We can define real world things like animals and cars and food and cats. As we see here, we have this cat. So with object-oriented programming, we can define things like cats in our code. So what we have learned, such as lists and strings, are examples of objects. An object can contain data in the form of fields, also known as attributes, and code in the form of procedures, often known as methods or functions. Okay. So the two main aspects of a class, of an object, are its attributes and its procedures. Now, an attribute is things like, we could think of attributes as variables, just regular old variables. And we could think of procedures as functions or methods, the things that we've been working with this entire time. So whenever you see attributes, just think of variables, which we all know what they are. Things like I is equal to 0 or J is equal to 20. And whenever you see procedures, just think of functions like def find sum or something. We've been learning about functions. Does that make sense to everyone? All right. So while objects are an encapsulation of variables and functions into a single entity, objects get their variables and functions from classes. Classes are essentially a template to create your objects. They can be thought of as blueprints for creating objects. Now that's a really good way to put it, the difference between a class and an object. So for you guys, think of a class as like a blueprint for an object. When Python wants to create an object, it looks for a class for that object, and it uses that class to create an object. Okay. So classes are just templates to create objects. Python is an object-oriented programming language. It does adopt the object and class concept. Actually, the class is a fundamental building block. It is the underpinning for not only many popular programs and libraries, but the Python standard library as well. Understanding what classes are and when to use them and how they can be useful is essential. So classes are pretty important, right? They're pretty fundamental in not just Python, but in most programming languages. So if you remember how to define a function, you will know what def does. In the class, we use the class keyword to define a class. And I'll show an example here. So this code right here is an example of defining a class. So I'll paste this onto our IDE and we can see what this is about. Yep. So this is a very simple Python class. We have the class keyword followed by the name of the class, which we just call my class, followed by a colon. So this is pretty similar to how we would define a function. So this I is equal to 1, 2, 3, 4, 5. This is an example of an attribute for the class. So remember earlier how I said that that we could think of attributes as like variables? This is exactly what I meant. So an attribute for my class is I, which we set to 1, 2, 3, 4, 5. And then we also have a method or a function. I'll kind of use method and function kind of interchangeably, but there's a subtle difference between the method and the function. but for now, we could just think of them as the same thing. So we have a method here called f, and we define it the same exact way that we define a function, except in the parentheses, we add a cell, okay? We add a cell, and then we just return hello world for this function. So this is a very basic example of a Python class. Does anyone have any questions about the syntax of creating a class like this? All right. So a Python class is defined using the keyword class. Oh, no. The Python class is defined using keyword class. A class can have properties, which is I in this case, and methods, which is F in this case. So to reference a class, you have to instantiate an instance of the class. So going back to our code quickly, the I here is a property of my class, and F is the method of my class. Okay, property and method. So here we're going to try out creating an instance of a class, which we call instantiating a class. So we can do it like this. We can have a variable called test_me that's equal to my class. And we kind of call my class like a function almost. And then we could use all the things that are in my class. So if we run this, we'll get hello world. Why do we get hello world? Well, because we have this print statement here that calls test_me, which is the variable name, and then we do .f, which calls the function. Okay. So when we instantiate a class like this, we have access to all of the attributes, or rather, we have access to all the properties and the methods of the class. So right here, I just showed an example of how I have access to the f function in my class and the I and the I variable, because I created an instance of my class. So I have a question for you guys. Let's say that I have a variable j that I'm called test, that I'll call Python. Okay. Can somebody tell me how I can access the value of j? So I added another property, another attribute to my class called j. How can I print out the value of j, knowing that I have test_me? Okay, I'll give a hint. It's going to be test_me.something. Now, what should I put after the dot in order to print out the value of j? Can anyone tell me that? Right, so I have to put j, test_me.j, in order to print out the value of j. So by doing test_me.j, I'm able to have access to the j variable that I just created in my Python, in my class attributes, and I was able to print it out. Now, does anyone have any questions about the properties and methods of a class and how to instantiate a class? Okay. So to access the method, you have to use the parentheses. To access the properties, you do not need it, which I just gave an example of. Okay. All right. So the self parameter is a reference to the current instance of the class and is used to access variables that belongs to the class. It has to be the first parameter of any function in the class. You can use it to refer to the attributes of this instance. That is why a method in a class has this extra parameter, which when you use the method, you do not need to provide a value for it. What is the slide talking about? It's talking about this self keyword right here. So when you have a class and you define a method in that class, you have to always put the self keyword in the parentheses to tell Python that this is a method for the class. Yep, that's what self does. You do not have to name itself, actually. You can give it a different name, but it must be the first parameter in any method. Usually developers use self because it is convention. See this example. So in this example, we're defining a class person where we have my silly objects as the first name, and then some other stuff. Now, when you guys are programming Python in the real world, please don't call your first class variable anything other than self, because you'll probably make other people working on your code a little upset because they're expecting the first parameter name to be self, because that's usually what developers use as a convention. All right, so in this example, the first parameter name is my silly object. This is just an example to show that it doesn't have to be self, but when you're coding in the real world, you should make it self because that's what people are expecting. So yeah. All classes have a function called init. Well, it's actually 2 underscores followed by init, followed by another 2 underscores, and then an open and close parentheses. Now, init is called the constructor of a class. This function is always executed when the class is being initiated. If you do not have such a function in your class definition, the system will use the parent's constructor. The parent class of all in Python is object, which has this function. Now, what does this all mean? It means that the init function is always called when a function is instantiated. And it's called even if you don't explicitly declare it in your class definition. So going back to our class example code, can anyone tell me if my class has a constructor in it? Right? Does anyone see if my class has a constructor? Right? My class does not have a constructor, and it does not have a constructor because it does not have the init constructor. This class would need something that looks like def init, something like this. So this is an example of a constructor. Okay, this def init. So the point of this step in it is that this is called whenever my class is instantiated like it is down here. So right now it does nothing, but we could always make it do something. We could have it do printf actually, self.f. So if we were to run this, oh, you have a question. Oh, for some reason my, yeah, thank you, Audrey. I don't know why it's not showing my code. Whoops. I've just been speaking to the void this entire time. Okay, yes, sorry about that. You guys should be able to see my code now. Okay, see where do I start over from? Okay, so before my class didn't have a constructor, but I just created an example of a constructor here with def in it. So if I were to run this, well, it's sorry. I think I need to add that. Yeah, and so I could call the method. Yep. So by adding a constructor, we printed out the value, or rather, we're calling the f method here. I know this is kind of confusing, so I'll just slow down a little bit, especially since I forgot to share my code for like 5 minutes. Anyway, to summarize, this code right now does not have a constructor because it didn't have a def in it. Okay. But if we were to show this code, for example, this class person, this code does have a constructor because it has the init function right here. Man, I wasn't sharing my screen this entire time. Yikes. Okay, anyway, moving on. So this is very useful when you need to assign values to object properties or other operations that are necessary to do when the object is being created. Once it is defined with other parameters, you will have to provide values when you initiate an instance. So this is saying that constructors are pretty useful when you want to populate or assign values to objects to class attributes. It's pretty useful there, and do other things that are necessary when an object is being created. So we have another example of a class here. So we'll look at this example closely. Okay, let's take a look at this example. So we have a class student, which is, so this class student is supposed to model what a student would be. And we're modeling that in Python. Now, can anyone tell me if this class, if this student class has a constructor? Okay. This class does have a constructor because it has the init method here. Okay. Whenever you see an init method, that means the class has a constructor. Make sure that you guys understand that. So in this function, we are setting self.name to be equal to name, and we're setting self.age to be equal to age. Now, can anyone tell me if this class student has any methods in it? Okay. So let's see. Well, that's actually close, Audrey. So the name and age are an example of the attributes to this class. So whenever you see things that look like variables like this, think of attributes. Okay. So the methods in this class the method in this class is actually prints info. See, a method is like a function. It's like a regular function that we've been working with, but they're just for classes. The method in this class is called print info, and it just prints out the self.name and self.age. Okay, so does anyone understand what this class, the definition of this class is? Okay, good. So let's instantiate this class and play around with it a little bit. Okay. Yep. So I'm going to move this stuff down actually. Okay. So we have so this line right here. This is an example of instantiating the student class so that we can create an object. Okay. So ST1 is an example of an object. It's a student object. So if we run this, we'll get we'll get some outputs. So we kind of instantiate this a student object in much the same way that we call a function. So the student class is asking for a name and an age. So that's exactly what we're putting into our object instantiation. We put John as the name and 36 as the age. And then we could also print out the name and age directly from the class, from our objects. And then we could also call the print info method with the st1 dot print info syntax. So remember the st1 is the name of our objects, and then we follow it with a dot, and then we do print info to call the print info method for that object. So that's why we get the outputs that we're getting here. Okay. Now there's a bit of a problem with st2. So in st2, we are st2 down here. We try to instantiate an instance of the student class, but there's going to be a problem. Can anyone tell me what the problem is going to be, or what the problem with this line here is? Now, what is the difference between this class instantiation in line 15 and this class instantiation in line 19? What's the main difference? Yes, Henry?
Is there something missing in between the two? What do you call them? Like
parentheses?
Yeah.
Yep, there is something missing. So in our class definition, and remember that classes are pretty much like blueprints for an object. In our constructor, we need to pass in a name and an age. But in ST2, we don't pass in anything. So if we try to run this, it's going to give an error. And it's going to tell us exactly what our error is. It's saying that there's a problem with ST2. And it's saying that student.init is missing 2 required arguments, name and age. Okay, does that make sense to everyone? All right. All right, let's move on. You can delete properties on objects by using the del keyword. Example, delete the age property from the st1 object. You can do that with del st1.age. Okay. So yeah, all right. So now we're going to try to create an instance of our own class. So we're going to create a teacher class with the name, subject, and grade as the required fields. This class will have 3 extra methods: get name, that will return this teacher's name, get subject, and get grade. So let's create this class together. I'll just create it here, actually. So def, oh, not def. Okay, so I'll ask you guys, what is the Python keyword for creating a class? The Python keyword for creating a class is just class. So we'll call our class teacher. Okay. And for our class, we need to have a constructor. So we could do that with def init. Remember def init, this is how we create a constructor for a class. So for a class, we need to have 3 things: the name, the subject, and the grade. Okay, so can anyone, actually, I'll just type it up. So we need self.name is equal to, and I forgot some things here. I need to add name. So to the constructor, I need to add the name, the subject, and something else. What else do I need to add? And the grade. So this will make it so that when we create an instance of the teacher class, that the programmer will need to put in the name, subject, and grade. We'll make self.name is equal to name, self.subject is equal to subject, and self.grade is equal to grade. Okay. Now, can anyone tell me what name, subject, and grade, what they are examples of? Are they fields or are they methods? They are examples of methods, and they're methods because they look like variables. Now, finally, we need to define some methods for this class. So we'll define get name, which just returns self.name. We need def get subject, which will just return self.subject. And we need def get grade, which will return self.grade. Okay, so with this syntax here, we created 3 fields and 3 methods for our teacher function. So we can instantiate an example of the teacher class with something like this. We'll call teacher subject Python 2, and grade, I'll put 5. You guys are 5th graders, right? Yeah. So if we were to run this will run with no problem. And this is where I'll leave a little extra assignment for you guys. So for an exercise for you guys, I want you guys to take this code and then print out T1's T1's name, subject, and grade. Okay, so I'll be a little exercise for you guys once I post this up. Okay, I know I went through this kind of quickly, but I wanted to give you guys this exercise before the end of class. Does anyone have any questions about classes and instantiating them and whatnot? Okay. I suppose that's it. It's about 7:30 now, so that's the end of class. Hope you guys got something out of this. And I'll see you guys next time.
Bye.